The next item they ask us to take a look at is computing a test statistic. And all that you really need to think about a test statistic being is what we were finding in chapter 6. In chapter 6, we were finding z-scores. We were finding how many standard deviations away we were for a particular value. And that's what our test statistics really are here for, proportions and means. Z-scores and t-scores just stand for how many standard deviations away we are from what's expected. You know, in this case, it's going to be how many standard deviations away from the claim mean, claim proportion. And what you see in the test statistic formulas is it's just observed value. That's what the p-hat is. That's what the x-bar is. Minus the p or the mu, that's the claim mean or the claim proportion, and then divided by the standard deviation. Now, when we're taking a sample, we're taking n items. Back in chapter 6, in 6.3 when we looked at sampling distribution, 6.4 when we looked at the central limit theorem, we saw that we ended up, for the sampling distribution, we had an n at a time standard deviation. So in 6.4, we saw that our new standard deviation was the original standard deviation divided by the square root of the sample size. So all that we're seeing here in these test statistics is an n at a time standard deviation being used to find out how far away that we are. And what do we know from the rule, the range rule of thumb? If we tended to be more than 2 standard deviations away, if our z was more than 2, our t was more than 2, then we tended to be significantly high, significantly low. We're going to see very similar things here. So what they wanted you to do in 13 and 15 is compute the test statistic. And this is where we're going to bring in the sample data. So for number 13, they go back to number 5. And, so I said back here, when we were running through this, we didn't care about the sample information yet. We only cared about the claim when we were putting together the hypothesis statement. Once we got the hypothesis statement, now we do care about the sample information. And what we're seeing in the sample information is we're getting the sample size, we're getting the sample proportion. And that's what we took down here. There's our sample size, there's our sample proportion. The number that was in the claim or the hypothesis statement that is our claim proportion. And then the only other thing that we need for the formula is the complement of the claim proportion, that's Q. So once you go ahead and plug these in, evaluate it, and what we see here is our result is more than 4 1/4 standard deviations away from what we would expect. In exercise 5, we were using a claimed proportion of 50%. We got a sample proportion of 59%. Is that close enough? Is it not close enough? What we need is we need to put that into terms of how many standard deviations away that is. This is over 4 standard deviations above what we'd expect to get if 50% is true. That's not looking to be true. In number 15, they say go back to exercise 7, and there we see a sample of 153 adults. There's N. A mean from that sample, so that's a sample mean, that's X bar. And a standard deviation from a sample, that's going to be S. So a sample size of 153 people, a sample mean of 69.6, a standard deviation of 11.3, and then there was a claim that the mean was 60. So since we're using the sample standard deviation there, we plug it into the formula for t here. And when we go ahead and evaluate that, we get a z-score of 0.66. So we're only about 2/3 of a standard deviation away from our claimed mean there. So that's not really all that far at all. And again, z's correspond to normal distributions. So if there's our normal distribution, a z of 0.66, that's not that far away. So if we're going to go ahead and look at the tail this thing generates, that's generating a pretty big tail. There's a lot of probability if we look at the probability of getting a sample result like we got or something more extreme. But we're going to actually get to more of this stuff a little bit later on. So let's just get rid of that for now. Thanks.